Hi guys, let's look at the last exercise of this chapter, ratio and proportion, which is exercise 7D. Basically a revision exercise, so no new concept for me to teach. So before we start, let's go ahead and revise certain properties and whatever we've learned in this chapter. So for the revision, we started with proportion, which is four non-zero terms are said to be in proportion if A is to B is equal to C is to D. And what this means is A multiplied with D is equal to B multiplied with C. A and D are the extremes, B and C are the means. In the ratio, in the fraction form, it can be written as A upon B is equal to C upon D. Next, we talked about continuous proportion, which is three non-zero terms are said to be in ratio or are said to be in continued proportion if A is to B is equal to B is to C. In this case, B is the mean proportional. This would be written as B square is equal to AC. And in the fraction form, we'll write A upon B is equal to B upon C. Then we talked about certain properties of proportion, which was if A upon B is given equal to C upon D, then we talked about five different properties. First one, if I take the reciprocal of both the sides, which means B upon A would be equal to D upon C. This property is known as invertendo, which is you inverting the terms on both sides. Next one was alternando, where you replace the denominator of one, you put the denominator of one in the numerator of the other, and the numerator of the second one in the denominator of the first one, which means A upon C would be equal to B upon D. All you've done, you interchange the numerator and denominator. This is known as alternando. Next was when we added 1 to both the sides, and that gave us A plus B upon B is equal to C plus D upon D. This was componendo. The next one was dividendo, where we subtracted 1 from both sides, and that gave us A minus B upon B is equal to C minus D upon D. This was dividendo. And in the end, we had componendo and dividendo together, which gives us A plus B upon A minus B is equal to C plus D upon C minus D. This is componendo and dividendo put together. From the exam perspective, you can be assured that you will get two questions from this chapter. One usually from componendo and dividendo, and the other one from using the K method, usually using the K method. Okay, let's go ahead and look at the questions. So the first one we have is question number 3. Let me remind you, ratio is not in syllabus, and since this is a revision exercise, questions which I have written here at the bottom, they are not in your syllabus. So we will not be doing them, and there's no point in you doing it because that's clearly not in your syllabus. Okay, next question, or rather the first question of this video. If term 1 is to term 2 is equal to term 3 is to term 4, find the ratio of x is to y. So let's start with using componendo and dividendo and see if we can remove some of these terms. So what we get is 3x minus 4y plus 2x minus 3y upon 3x minus 4y minus 2x plus 3y is equal to 5x minus 6y plus 4x minus 5y divided by 5x minus 6y minus 4x plus 5y. Let's see what do we get. This is 3x plus 2x, 5x, negative 4y minus 3y, that's negative 7y, 3x minus 2x, x minus 4y plus 3y, negative y. 5x plus 4x, 9x, negative 11y, and x minus y. Multiplying both sides by x minus y, this gets cancelled. So what we are left with is 5x minus 7y is equal to 9x minus 11y. Let's bring like terms together. So we have 9x minus 5x is equal to negative 7y plus 11y. This gives us 4x is equal to 4y, which means x is equal to y, which means x is to y is equal to 1 is to 1. Perfect, that's our answer. Because they wanted it in the ratio form, I have written in the ratio form. Had they asked for x upon y, my answer would have been 1 upon 1, or you can also write it as 1. Okay, let's go ahead and look at the next question. The next question that we do is question number 9, part 1. It says find the fourth proportional of these terms. So let fourth proportional proportional be A. So if we have fourth proportional be A, then we have 2xy upon x square is equal to y square upon A. Since they want us to find the value of A, which is the fourth proportional, let's make it the subject. So A would be equal to x square into y square upon 2xy. X and the second power gets cancelled, y and the second power gets cancelled. So we have xy upon 2. So the fourth proportional is xy upon 2. The next one is question number 9 for 3. It says mean proportional to these two terms. So we need to figure out the mean proportional. So let mean proportional be A. So what we have is x minus y upon A is equal to A upon x cube minus x square y. I notice x square is common between these, so let's write it in this form. X minus y upon A is equal to A upon x square x minus y. Let's cross multiply. So we have A square is equal to x minus y multiplied with x square multiplied with x minus y, which gives us A would be equal to the root of x minus y whole square multiplied with x square. Therefore, A would be equal to plus or minus x multiplied with x minus y. So that's our answer. The mean proportional is plus minus x times x minus y. Next question. I hope you like the video. If you have any questions or queries, please feel free to write into me. Okay, next question. That's question number 12. It says if x is equal to 2ab upon a plus b, find the value of x plus a upon x minus a, x plus b upon x minus b. I notice that if I have the value of x upon a and I apply componendo and dividendo on it, I will get this term. And if I have the value of x upon b, if I apply componendo and dividendo on it, I'll get the second term, which means I need to figure out x upon a and x upon b. X is already given, so I guess it should be easy for us to figure out x upon a. So let's go ahead and do it. X is equal to 2ab upon a plus b. So since I want x upon a, let's divide both sides by a. This will give me 2b upon a plus b. Now using componendo and dividendo, we get x plus a upon x minus a is equal to 2b plus a plus b upon 2b minus a minus b. This gives me x plus a upon x minus a is equal to 2b plus b, that's 3b plus a, and this is 2b minus b, that's b minus a. That's my first equation. This should help me find the value of what they want. Good. Let's look at the next one. The next one we have is x plus b upon x minus b. Okay, so we know the value of x, which is equal to 2ab upon a plus b. Let's divide both sides by b. We get x upon b is equal to 2a upon a plus b. Using componendo and dividendo, we get x plus b upon x minus b is equal to 2a plus a plus b upon 2a minus a minus b. That gives us x plus b upon x minus b is equal to 3a plus b upon a minus b. Now I've got the value of the first term as well as the second term. Let's go ahead and add them. So add, let's call this equation number 2. So add equation 1 and equation 2, and we get on the left hand side is x plus a upon x minus a plus x plus b upon x minus b, and this is equal to 3b plus a upon b minus a plus 3a plus b upon a minus b. I notice the denominator is exactly the same except for the signs are reversed, which means I can change the sign between these two terms and that will change my denominator sign. So this will become 3b plus a upon b minus a minus 3a plus b upon b minus a. Now the denominator is exactly same, which means I can take the LCM as b minus a, and this would become 3b plus a, 3b plus a minus 3a minus b. I hope you noted there is a bracket here which is not there, which means the subtraction is being done for both the elements in the numerator, which means the sign of both the elements changes. So 3b minus b, that's 2b, a minus 3a, that's negative 2a upon b minus a. I have 2 common between these two elements in the numerator. So 2 times b minus a upon b minus a. B minus a and b minus a gets cancelled. So the value of what they want is equal to 2. So this value is 2. That's exactly what they wanted. Let's go ahead and look at the next question. The next question that we do is question number 14. It says if A upon B is equal to C upon D, show that this ratio is equal to this ratio. Basically, they are in proportion. Okay, so let A upon B is equal to C upon D is equal to K. So we are taking it equal to K. What this means is A is equal to BK and C is equal to DK. Now let's try and look at what we have in the left hand side. So on the left hand side, we have A plus B upon C plus D, which is equal to A, which is BK, plus B upon C, which is DK plus D. I have B common in the numerator, so this is B times K plus 1. In the denominator, I have D common, this is K plus 1. K plus 1, K plus 1 gets cancelled, which means left hand side is equal to B upon D. Let's figure out the value of right hand side and see if we can also make it equal to B upon D. So now let's work with right hand side. The right hand side is A square plus B square, the square root upon C square plus D square, the square root. Let's substitute A square as BK. So this is BK whole square plus B square, the square root upon C is dk, which is dk whole square plus d square, the square root. Now the numerator becomes b square k square plus b square root upon d square k square plus d square. Let's take b square common in the numerator. So this is b square times k square plus 1, and in the denominator d square is common, k square plus 1, and there is square root on both these elements. K square plus 1 and k square plus 1 gets cancelled, which means this is b square upon d square, which is equal to b upon d, which means b upon d is equal to RHS. So from 4 and 9, we get LHS is equal to RHS, which in this case was equal to B upon D. So hence proved. Good, let's look at the next one. This was a fairly simple one. The next one is question number 16, part 2. Question number 16, part 2 says if 7x minus 15y is equal to 4x plus y, find x is to y. Okay, so let's bring like terms together. So we have 7x minus 4x is equal to y plus 15y. This gives us 7x minus 4x, that 3x is equal to 16y, which means x, that's point number 3, not 4. Point number 3 would be x upon y is equal to 16 upon 3. They want it in the ratio form, so we will write it in the ratio form. X is to y is equal to 16 is to 3. So our first part of the question is done. Now they want the value of 3x square plus 2y square. Okay, so this to me looks like if I can figure out the value of 3x square upon 2y square, then if I apply componendo and dividendo on it, I will get 3x square plus 2y square upon 3x square minus 2y square. So basically I need to find the value of 3x square upon 2y square. First, let me figure out the value of x square upon y square. So x upon y whole square would be 16 upon 3 whole square. Yes, that'll help me find the value of x square upon y square. So that's x square upon y square would be 16 squared. That's 256 and 256 and 3 square is 9. So we figured out x square upon y square. Now we need 3 by 2 as well. So let's multiply both sides by 3 by 2, which gives me 3x square upon 2y square is equal to 3 into 256 upon 2 upon 9. 3 1, 3 3, 2 1, 2 1, 2 8. So we have 3x square upon 2y square is equal to 128 upon 3. Right, that's correct. Now, using componendo and dividendo, what we get is what number 9, 3x square plus 2y square upon 3x square minus 2y square is equal to 128 plus 3 upon 128 minus 3. 128 plus 3, that's 131. 128 minus 3, that's 125. So that's our answer, 3x square plus 2y square upon 3x square minus 2y square is equal to 131 upon 125. You can also write it in the mixed fraction form, 1 6 upon 125. Perfect. That's the final value. Good. Let's look at the next question. The next question that we do is question number 17. Question number 17 says, if 4m plus 3n upon 4m minus 3n is 7, we need to find the value of m is to n. Perfect. So using componendo and dividendo, that should remove the value of m and n. That should remove m or n from either the numerator or denominator. So what we get is 4m plus 3n plus 4m minus 3n upon 4m plus 3n minus 4m plus 3n will be equal to 7 plus 4 upon 7 minus 4. 3n and 3n, 4m and 4m gets cancelled. So we have 8m upon 6n is equal to 7 plus 4, 11 upon 3. That's 2 into 3, 2 into 4, which means m upon n is equal to 11 into 3 upon 3 into 4, basically cross multiplying. 3 and 3 gets cancelled, which means this is equal to 11 upon 4. They want it in the ratio form, so my answer would have to be in the ratio form. M is to n is equal to 11 is to 4. Right, that's the first part of the question. Let's look at the second part of the question. The second part of the question is find the value of 2m squared minus 11n squared upon 2m squared plus 11n squared. Again, I hope you notice if I can find the value of 2m squared upon 11n squared, I will and apply componendo and dividendo on it, I should get this, but with the positive sign in the numerator, negative sign in the denominator. So the key is first to figure out the value of 2m square upon 11n square. Now that we know m upon n, let's figure out the value of m upon n whole square. That'll be 11 upon 4 whole square. That'll be 121 upon 16. Now we need to figure out the value of 2m square upon 11n square, which means 2m square upon 11n square would be equal to 121 upon 16 into 2 upon 11. 11 1, 11 11, 2 1, 2 8. So this is equal to 11 upon 8. That's the value of 2m square upon 11n square. Now using componendo and dividendo, we get 2m square plus 11n square upon 2m square minus 11n square will be equal to 11 plus 8 upon 11 minus 8. 11 plus 8, 19, 11 minus 8, 13, and this is equal to 2m square plus 11n square upon 2m square minus 11n square. But in the question, they want the negative sign in the numerator, which means we are looking at taking reciprocal of both sides, which is known as invertendo. So using invertendo, which means reciprocal of both sides, we get 2m square minus 11n square upon 2m square plus 11n square is equal to 3 upon 19. That's our final answer. Good, let's look at the next question. The next question that we have is question number 18. Question number 18 says, if x, y, z are in continued proportion, we need to prove that x plus y whole square upon y plus z whole square is equal to x upon z. This question appeared in your board exam in 2010. So like I have said, usually you would end up doing the continued proportion sums using the K method. That's the usual method that you will use. Let's try if it works here. So x upon y is equal to y upon z is equal to k. So let it be equal to k, which means x is equal to y, okay, y is equal to zk, which means x is equal to, instead of y, if I put zk, I will get x is equal to zk square. Okay, now let's look at the left hand side. So our left hand side is x plus y the whole square upon y plus z the whole square. That would be equal to x. Instead of x, I'll write zk square, plus instead of y, I write zk and the square of this, divided by y plus z. Y is zk and z is z the whole square. Let's see if I have anything in common in the numerator. So between zk square and zk, I have zk common. So let's take zk out. What remains from the first term is k. What remains from the second term is 1. And we have square of the whole thing. In the denominator, I notice z is common. So let me take z out. What remains is k plus 1. And this is the whole square. Let's do the square of this separately. So this is z square k square upon k plus 1 the whole square divided by z square multiplied with k plus 1 the whole square. K plus 1 the whole square and k plus 1 the whole square gets cancelled. Z square and z square gets cancelled, which means we are left with left hand side is equal to k square. Now let's see, we can prove right hand side also equal to k square. Let's try. So our right hand side is, this is point number 8, is equal to x upon z. Now x is equal to zk square, z is z, that gets cancelled. Therefore, right hand side is equal to k square. That's point number 9. So from point number 7 and point number 9, we get left hand side is equal to right hand side is equal to k square. Hence, proof. That's exactly what they wanted us to show. Now here, let me remind you, 3 methods which you can use to prove left hand side equal to right hand side. 1. Start working with left hand side and prove it equal to right hand side by solving it. Next, start working with right hand side, solve it and prove it equal to left hand side. Third method, which is work with left hand side, make it equal to, let's say, a number x, work with right hand side, let's say make it equal to the same number x, both of them are equal, that's why left hand side and right hand side are equal. Any operation which involves cross multiplying or taking one element on the other side for proving left hand side equal to right hand side is not allowed as per the council. Okay, that brings me to maybe the last question of this video. Yeah, okay. So let's look at this question, which is question number 19. It says, given x is equal to square root something something, prove b square is equal to 2a square x upon x square plus 1. Okay. So first, let's go ahead and use componendo and dividendo. They'll help us remove some element. So using componendo and dividendo, I get x plus 1 upon x minus 1. Right, the denominator here is 1. So x plus 1 upon x minus 1 is equal to a square plus b square plus a square minus b square plus a square plus b square minus a square minus b square. Yes, everything is in the square root sign. I will put them right at the end. Perfect. So that's my numerator. And in the denominator, I have a square plus b square plus a square minus b square minus a square plus b square plus a square minus b square. And everything is in the square root sign. So this term and this term gets cancelled. First term and third term gets cancelled. So what we have is x plus 1 upon x minus 1 is 2 times root of a square plus b square divided by 2 times root of a square minus b square. 2 and 2 gets cancelled. Now I notice that I need to have the value of a as square, which means I should square both sides. So squaring both sides, I should be able to remove the square root sign as well. So squaring both sides will give me x plus 1 whole square and x minus 1 whole square, and the right hand side would become a square plus b square upon a square minus b square. Okay, let's see what we can do from here. Okay, so that's point number 4. When I square x plus 1, that becomes x square plus 2x plus 1. In the denominator, I have x square minus 2x plus 1, and this is a square plus b square upon a square minus b square. Maybe I should do componendo and dividendo once again so that I am able to cancel out some more terms. So using componendo and dividendo for the second time, I get point number 5. That's x square plus 2x plus 1 plus x square minus 2x plus 1 upon x square plus 2x plus 1 minus x square plus 2x minus 1. This is equal to a square plus b square plus a square minus b square upon a square plus b square minus a square plus b square. If this gets cancelled, negative b square plus b square gets cancelled. Here 2x and negative 2x gets cancelled, negative x square gets cancelled, 1 gets cancelled. So what we have in the numerator is 2 times x square plus 1. In the denominator, we have 2 times 2x. Here in the numerator, I have 2 times a square. In the denominator, I have 2 times b square. 2 and 2 gets cancelled, 2 and 2 gets cancelled. So what we have here is x square plus 1 multiplied with b square is equal to a square multiplied with 2x. What do we want? We want b square as the subject. Okay, so making b square as the subject, I get 2a square x upon x square plus 1. That's the value of b square. Perfect. That's exactly what they wanted us to prove. We've been able to do it. Interesting question. We used a couple of concepts. First, we did componendo and dividendo once, then we squared both sides, then we used componendo and dividendo second time. That should end this video for me. Before I leave, let me mark some homework questions for you. That would be question number 2, question number 9 part 2, question number 10, and question number 13, question number 16 part 1. That's it. Thank you so much. Take care. Be safe. If you have any questions or queries, feel free to write into me. Bye bye.